So, if you've ever had to work with a remote server, maybe deploy an application, or just manage some infrastructure, you've definitely run into these three letters, SSH. It is, without a doubt, one of the most essential tools out there. But what exactly is it, and what makes it so powerful? Well, let's dive in and break it all down.
You've probably been there, right? You're sitting at your desk, deep in the command line of a machine that could be on the other side of the planet, and this thought pops into your head. How do I know that the commands I'm sending or the data coming back isn't being, well, spied on? It's a really important question, and luckily, it has a really solid answer.
And yeah, that answer is SSH, which stands for Secure Shell. At its core, it's basically a protocol, a set of rules, that's built for one main job: to create a completely secure, totally encrypted channel between your computer and some remote machine. The best way to think about it is like a private, armored tunnel running right through the public internet.
And the things you can do with it? Oh, it's incredibly versatile. We're talking about getting direct command line access, securely zipping files back and forth with tools like SFTP or SCP, deploying entire applications, and doing all that critical server maintenance. To put it simply, it's pretty much the bedrock of how we manage remote systems securely today.
So, how does this secure conversation even get started? Well, when you boil it all down, an SSH connection is just a dialogue, a talk between two computers, what we call a client and a server. So on one side, you have the client. That's you. That's your local machine, the one that's kicking off the connection. And then on the other side, you've got the server. That's the remote machine, and it's just sitting there listening for those connection requests to come in.
Okay, this brings us to what is arguably the most important piece of the whole puzzle: authentication. I mean, how does that server, just listening out there on the internet, know that the request it's getting is actually from you and not from someone just pretending to be you? How does it verify your identity?
Well, it turns out there are two main ways SSH handles this. Two totally different methods for proving you are who you say you are. The first method is good old password authentication. We all know it, it's pretty simple, but let's be honest, it's also really vulnerable. It can be guessed, it can be brute forced, it can even be intercepted. The second method, which is way, way more secure, is using something called SSH keys. This is a cryptographic approach, and it's the professional standard for a very good reason. And that's what we're going to focus on.
So how do these keys actually work? Honestly, the best way to wrap your head around them is with a simple analogy. Just picture a really unique special lock and a key that only you have.
This whole lock and key system works because of a process that's kind of like a secret multi-step handshake, and it all happens in the blink of an eye. There are 5 main stages, and it all starts, as you might guess, with generating the keys themselves. Right, so it all begins on your machine, the client. You generate what's called a key pair. First, there's the public key. You can think of this as the lock. You can make copies of this lock and put it anywhere, like on your remote server, no problem. But then there's the private key. This is your secret. You must never, ever share this. It stays right there, safe and sound, on your local machine. Now, when you try to connect, the server sees your request. It already has your public key, your lock, remember? So it gets clever. It creates a random message, locks it up tight with your public key, and sends this encrypted challenge back to your machine. And here comes the magic. The only thing in the entire universe that can unlock that message is your secret private key. Your client gets that encrypted challenge, uses your private key to easily decrypt it, and then sends the original, now unlocked message right back to the server as its response. So the server gets the response, and it checks, hey, does this match the original message I sent out? And if it does, bam, the server has absolute proof that the client has the matching private key. It knows it's you. Identity confirmed, access granted. And that's it. That's the end result. Once that secret handshake is complete, a totally secure, fully encrypted session is established. From that moment on, every single command you type, every file you move, it's all protected from anyone trying to listen in. So why does any of this matter? Why go through all this trouble? Because this cryptographic handshake, this is the very foundation of how we securely manage things remotely. It's what allows us to look after the digital infrastructure that powers our entire world and do it safely and reliably. So now you know what's actually happening under the hood every single time you type SSH. It's not just a command, it's a whole cryptographic dance ensuring your security. Which leaves just one question, right? Are you making sure all of your connections are protected with SSH keys?